Welcome to my kcse revision channel, Teacher James Marita, Kilgold Boys High School. Kindly subscribe my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at kcse revision from 1 work, and we are looking at some diagrams of signs, hazard signs, and also the separation of substances. We have also the change of state. These are very simple summary from 1 work. That we have the first diagram is indicating change of state, whereby a solid will change to liquid, then liquid to gas. So we have a solid, then we have a solid will change to liquid, and then it can change to gas. So what we are supposed to know here is that you know that from A, where a substance can change from a solid to liquid. So this process is just called melting, or it is called fusion. Then we have a liquid can just change to gas, whereby we are talking about boiling, or you can talk about evaporation. And then we have a substance can change directly from a solid to liquid, solid to gas, and that part is represented by E. This process is called sublimation. So in this process of sublimation, then the substance can also change from gas to solid. So from a solid to gas, we call it sublimation. From a gas to solid, back to liquid, back to a solid is called deposition. What are some of the examples that undergo such process? If you will be asked to give the examples which undergo such process, you mention of aluminum chloride, you mention of iodine, you mention of benzoic acid. Those are some of the examples of substances which can undergo sublimation, at the same time also they can undergo deposition. Then we have also where this one here, a gas can change back to liquid. So when a gas changes back to liquid, what is that one here? So this one is called condensation. And then we have a liquid can also change back to liquid. That one is called freezing. So this is a simple diagram representing the change of state. We have the other part where now we talk of the hazard signs. This is a situation where most students don't know the meaning of these signs. So when you come across in an examination and then you have these signs, what are their meaning? What does it mean in chemistry? We call them the Servant reparatory rules, or we call them the hazard signs. So the hazard signs, normally these are the signs giving us signals that there is some dangers. For example, if you have this one, we have 100 something here. If you can see this diagram, this means that the substances are very corrosive, or maybe the liquids are very corrosive. So this one represents for corrosive. We have another one here. When you see this diagram here, these signs it indicates that, or it signals that the substances are very explosive. We have another one here. This one here, you can look up from your screen that this one is flammable, substances which can catch fire easily. Then we have the other one here, this one like a cross. When you see this sign, it's indicating that the substance is just irritating. We have the other one. This one signals that the substance is oxidizing. We have this one also. This one represents that the substances are radioactive. Then we have this one where we have this one here. It signals that the substance are a pollution, so or pollutant. And then we have the last one. This one means as toxic. So these are the hazard signs. Normally they give the signals of some dangers. Now we have the separation of substances. We have various methods of separating substances. We have use of a magnet, we have decantation, and very many others. So I have some diagrams here where we are talking about now. What are some of the common diagrams normally we are expecting in an examination in the separation of the substance? The first one we have here is a mixture of water and acetone. Mixture of water and acetone, this one here, the water and acetone does not mix. They form what we call the heterogeneous mixture, or they are immiscible substances. immiscible substances, they are normally separated by the use of a separating funnel. So when it comes across this diagram, where you have the acetone, where you have water, so sometimes you will be given, you have this acetone and the water, and then you will be asked now, give the methods of separation. What is the suitable methods for separating this one? You know that water and acetone are immiscible substances, therefore they can be separated by use of a separating funnel. As you can see, we have acetone is floating on water. It means that these substances, the property makes them to be separated by this method. It is because they have different in densities. Then we have the other one here. As we have, this is a sublimation aside in the first diagram, where we have substances can change from a solid direct to gas. That process is sublimation. And then we have that substance can also change direct from a gas to solid. That process is called deposition. So we have this diagram where by now we have one examples which can undergo that process of sublimation and deposition. For instance, we are talking about iodine. So we have here the iodine crystals which is formed here, and then we have, this is a mixture of iodine and sand. So what do you normally observe on this diagram? What do you normally observe here? What is the observation? So you understand the observation and also the application of this sublimation. So what can observe here is that a solid iodine, it forms a purple vapor which cools to form a dark gray crystals. So here you can see a dark gray crystals. That is the main observation you can make from here. Then we have the application of this sublimation. We have some substances which undergo sublimation. One of the substances which undergo sublimation apart from iodine is dry ice. And therefore the application of this sublimation, you get that a dry ice is used in a cold boxes by ice cream vendors. And what makes this one here, this one is preferred to be used over the ordinary ice because it sublimes, hence it does not cause dampness. That is why now the dry ice is used in a cold process by the ice cream vendors. Now, sometimes when you are having this separation, when you are using this sublimation to separate iodine and sand, for example. So we have some other examples which can be separated by this method. For example, you talk of the ammonium chloride. Ammonium chloride, it does not undergo sublimation. Ammonium chloride normally it undergoes what we call thermal dissociation. And again, you can also have other examples. You can also have benzoic acid. You can also have the aluminum chloride. During separation of a mixture using this method of sublimation, a mixture is heated in a glass beaker covered with an evaporating dish containing cold water. As you can see, we have an evaporating dish, which is in this case containing the cold water. The substance that sublimes is collected underneath the cold water of the separating of this one here. And again, now that what happens here now that when that substance that which are being separated, collect and add this one here, it is normally scrapped. It is normally scrapped and it is placed in a different beaker. So in that process now they are being separated. So we have various substances which can be separated by the use of this method. Another common method which is used in separation of the mixtures is what we call the fractional distillation. In this fractional distillation, you have a single diagram here where you talk about we have a thermometer. A thermometer in this case here indicating the boiling point, and then we have the fractionating column. We have the glass pits. We have water out, and then we have water in. And then now this method of fractional distillation is normally used to separate water and ethanol, because water and ethanol, they are miscible liquids. And in this case, when they are miscible liquids, they have different boiling points. So therefore, they can be separated by this method. So what are you supposed to understand from this one here? It is this method. It is used to separate miscible liquids. For instance, they can use to separate water and ethanol. Water has a boiling point of 100 degrees, ethanol has a boiling point of 78. So because of that different boiling point, they can be separated. Then now, another thing, we have the fractionating column. What is the purpose of this fractionating column? The purpose of the fractionating column, it enables vapor liquids with a higher boiling point to condense and flow back to the flask. Then we have the glass beads. The glass beads here, it increases the surface area. So it increases the surface area for condensation. And then we have that the substances, the liquid with a lower boiling point, for example, ethanol with a lower boiling point, it has a boiling point of 78, it vaporizes fast, then followed by water. That is how this separation normally takes place. Then we have what property that makes the separation possible. What makes this water and ethanol to be separated by this use of the fractional distillation. So the property makes here is that they have difference in boiling point of the substances. So water and ethanol, they have different in boiling point. Water boils at 100 degrees, ethanol boils at 78 degrees. So because of that, the difference in boiling points now, they can be separated. Now, what are some of the applications of this fractional distillation? So the application of this fractional distillation, it can be used in the manufacture of wines and spirit, and also it can be used in the separation of crude oil. We have another diagram there. The name of this diagram is normally called the separating funnel. Separating funnel normally, as I've said earlier, that is used in separate liquids which does not mix. Liquids which forms immiscible air, liquids which forms immiscible. So which does not mix here in this case. So for examples of liquid which does not mix, you talk of oil and water. Oil and water, they have different densities. So to separate them, you can make the use of a separating funnel. So you can have a diagram. In this diagram, we have oil and water. So in the case of an examination, you will have this diagram, and then, for example, the oil will not be indicated, and then water will not be indicated. You will be given, for instance, oil as substance Z, and water as substance Y. Then you will be required to name the liquids. So if you are required to name the liquid, you say that we have water here, and then we have oil there. Because the oil and water, they have different densities. Now, what makes it possible to separate the substance? What makes it possible to separate the substance is because they have different densities, and again, they are immiscible liquids. They form what we call the heterogeneous mixture. Then we have the last part where we are talking about the effect of heat on hydrated copper-2 salivate. The effect of heat on hydrated copper-2 salivate. Hydrated copper-2 salivate, it contains water of crystallization. So when it contains water of crystallization, the hydrated copper-2 salivate, in this case, it is hydrated, it is blue in color. So what happens here, when you heat the hydrated copper-2 salivate, water will just evaporate, then you leave behind a solid of copper-2 salivate, which is white. Sometimes this one here, the hydrated copper-2 salivate is also a chemical test used to test to confirm that the liquid produced here is water. So what you understand from this diagram is that you can see the orientation of the boiling tube. The orientation of the boiling tube is slanted downward. So the boiling tube is slanted downward to prevent the condensed steam from flowing back into the hot boiling tube. The acid will crack the boiling tube. So the reason why this one is slanted downwards, it is just preventing the liquid water which will condense from flowing back, which may crack the boiling tube. Then we have the observation that you can make here is that a blue copper-2 salivate changes to white border, and then you have a colorless liquid on the cooler parts of the test tube. So that is the observation you can make from there, and the reason why the test tube is normally slanted downward. So these are very simple symbol diagrams representing for man work, and these are some of the diagrams normally expected and commonly tested on examination. So you can go through this one here. Then don't forget to subscribe, watch, and share. Thank you for watching.